Welcome to LabMinutes.com. In this video, we will look at EZVPN with certificate authentication using a Cisco router as a head-end device. The setup for this particular lab is almost identical to our previous lab with the pre-share key authentication. So if you have not watched our video or you're not familiar with EZVPN, I would highly recommend you take a look at the video, which has the codes SEC0016 EZVPN with pre-share key and XAuth authentication. Since the configuration is going to be very similar to that video, we're going to step through the configuration rather quickly, and I'm just going to highlight some of the differences that's related to the certificate authentication. Okay, so here again we have a router 1 head-end device and the router 2 being EZVPN client, and we're going to try to get the connectivity between the two VLAN, which is VLAN 132 and 128. We also have a Windows 2008 that's running a certificate authority server. Some of the certificates we have already installed on the routers. So to show you with router R1, we already have a trust point created with a certificate install. So if you do crypto PKI, okay, so we already have a trust point called LabMinutes. Let me do terminal length. Scroll up. You got a trust point called LabMinutes, and the certificate was enrolled or requested through SCEP. You show crypto PKI cert. You can see there's a certificate that belongs to R1 as well as the trusted root CA certificate. Okay, so let's start the configuration on R1. First, we'll turn on AAA authentication, but we're not going to do AAA authentication command because that's for XAuth, and we're not doing XAuth. We're just going to do certificate. So authorization network, and author local with IP local pool, EZVPN pool 16100.32 through 63 with the IP access list for our split tunnel. STACL with permit IP 192.16.32.0/24 to any. Okay, do crypto ISA policy 10 encryption AES 256 authentication. Here, instead of doing pre-share key, you're going to do RSA signature, although that's the option, the default option. Group 2 hash SHA, and we'll leave lifetime at default. Okay, we go crypto ISACamp keep alive at 10.3, interval 10, retry 3 times. Next we're going to do crypto the ISACamp configuration group. Called EZVPN group. Okay, with DNS server 172.16.32.40 with the domain of LabMinutes.com. Pool, EZVPN pool for the IP that gets handed out to the client with the split tunnel ACL of EZVPN split tunnel ACL. Allow the save password and enable PFS. Okay. Next, we're going to create ISACamp profile. EZVPN ISACamp profile. self identity, use address, match identity group, EZVPN group, SCEP authorization ties to the one we created earlier with the client config address respond, keep alive 10, retry 3, and instead of doing, let's see, one thing I didn't point out was under the configuration group with the pre-share key, usually we specify a key under that. Since we do a certificate, we did not enter the key command, but instead on the SCEP profile, we want to specify the trust point. So CA trust point, so the certificate that the R1 is going to be receiving from R2, it needs to know which trust point it will use to exchange the certificate, and also checking whether or not the certificate should be trusted. So trust point, earlier we called LM root CA. Root. Okay, so we have that. Then we're going to do crypto IPsec transform set. (256) SHA, so ESP AES 256 ESP SHA. Crypto IPsec. I'm going to clear the DF bit. Now under crypto dynamic map, EZVPN map 10, set security lifetime, gonna do 1 gig or 8 hours. The transform set, okay, PFS group 2, and then SCEP profile, which is what we have up here. And then enable reverse route. Okay. The crypto map, VPN map, again 1000 IPsec SCEP, tied to the dynamic map we created earlier, and then we enable the crypto map on the interface. Okay, so R1 should be ready. Now we're gonna jump to R2, and again, just to show you, R2 has a certificate install, although it's not really a correct certificate, because if you look at OU equal, for EZVPN to work with the certificate authentication, the OU equal has to specify the group name. So this one has the OU equal IT, which is going to be incorrect for us. But we already have another certificate prepared for R2. Just to show you right here. And show you subject right here. We have an OU equal EZVPN underscore group. So we're going to go ahead and install that certificate onto R2. Okay, so let's clear the screen. The next thing we need to do is create a crypto PKI trust point. Let's call it EZVPN CA. Since we're going to be doing a manual enrollment, so it will be enrollment terminal with the FQDN of r2.labminutes.com. So that should be R2. And with the subject name of cn equal same name OU, make sure it's matching your group name. So this time will be EZVPN group. LabMinutes CA yes. Revocation will be none. Okay, the first thing we need to do is to authenticate before we can use the trust point. So it'll be crypto authenticate PKI authn. Here, let me bring up the notepad. So we already have a root CA already, just to show you. It's a self-signed root. Paste that and quit. Okay. So we have installed the CA, root CA for the trust point. Next, we're gonna, instead of creating the certificate signing request, we actually went through that already and obtained this certificate. So we're just gonna go ahead and use it or import it. We're gonna do crypto PKI import with EZVPN CA, and we're gonna import certificate. Okay, copy all that and quit. You can see the certificate is successfully imported. If we do show cry PKI certificate, and now that we have certificate right here, that's associated to trust point EZVPN CA. Okay, so now that we have the certificate, let's complete our EZVPN client config. So policy, want to make sure it's the same encryption AES 256. Authentication will be RSA SIG. Group 2, hash SSA and default lifetime. Make sure we do crypto ISACamp keep alive 10.3. And then we get into the crypto IPsec client EZVPN. I'm going to call it EZVPN. Okay, connect, type auto. We want to do automatic connect. Mode, just do client, peer, which is the IP of the headend, 111.10. Make it a default with idle of 1 hour. Okay. Last thing we need to do is to specify inside-outside interface for the EZVPN. Outside, before I do the inside, I want to turn on debug so we can see what's going on. Crypto ISA, that should do it. On the headend side, and then we do in. Okay, so that's turned on. You see a whole bunch of debug messages coming through, and we have the loopback status changed to up. If you're trying to ping from a test PC, the ping are successful. ISACamp SA, it's good. Let me go back and kind of turn that off. IPsec SA is also good. We pinged 7 times and we saw 7 packets being encapped and decapped. Show cry IPsec client EZVPN. Okay, grab the 100.32 IPs without the parameter get pushed down, and the split tunnel subnet. Okay, so now let's just take a quick look at the debug messages. Scroll to the top. You can see it tries to match phase 1 policy, and eventually it matched AES to the keylink 256 SHAR group 2 and RSA signature. You can see the policies or the proposal is acceptable. Okay, so that's for the protocol suite negotiation. Let's see if we can find the line for the certificate. Okay, so got to main mode 3, phase 3, message 3 rather. Got main mode 4, and here you can see R2 sent a certificate with the OU group, EZVPN group. And you can see here how it pulls the group from the OU field. I can see where it says matches EZVPN ISACAMP profile. Okay, so OU equal again. And here where it says authentication is completed. And now we move on to the main mode message 5. This is where the R1 sends its own certificate. And here it said IKE phase 1 complete. Right, once that happens, all the attribute gets pushed out from R1. You can see the group successfully sent to R1. Again, phase 1 complete. And you can see all the IPs is allocated, the DNS server IPs, split tunnel ACL, domain name, and so on and so forth. So you can see the whole negotiation in this debug. Let's see if I can find something. So there's another line that I want to show you. So during that phase 1 process, that both sides perform NAT detection and see if either side is actually behind NAT device. You can see right here where it said no NAT found. Otherwise, it would have gone into the NAT transversal process. You see right here it said no NAT found. Okay, Surcry IPsec SA. Everything looks good. Same thing, symmetrical to R2, where say 7 packets in, 7 packets out. That's in ICMP request in and reply out. Okay, transform set, everything's right here. So you can do detail on this. If you do crypto ISACAMP SA detail, it shows you the IPs on both sides being active, encryptions, SHA, and you can say it said RSA SIG or RSIG for authentication. And the lifetime is 1 day or 24 hours. Okay, and the ping's still good, so certificate authentication has succeeded. You also have an option. So actually certificate authentication is just replace the pre-share key under the group. It's got nothing to do with XAuth. We just happen to turn off XAuth, which is the username password. So you can still enable XAuth concurrently with signature certificate if you want. But that might not see much benefit since the username password is still stored. If you want to do it the automatic way, you will still store the username password on the client side. In that case, all the command that you need for XAuth, which is like all the AAA authentication on the head end, and the client authentication needs to be configured, and the username password as well. But here I'm just going to keep things simple, and if it's sufficient for you just to do certificate authentication without the username and password on top of that, then this is all you need. Okay, so that wraps up our video on EZVPN with certificate authentication on a Cisco router. Thank you for watching LabMinutes.com. I'll see you guys in the next video.